I'd like to talk about the Millennium Tower and how what we have been talking about in chapters 11 and 12 relate to some real-world conditions. So let's talk about the project. The Millennium Tower is a 58-story skyscraper in the South of Market district, sort of like Soho in New York, in San Francisco. It is a mixed-use, primarily residential structure. It is the tallest residential building in San Francisco and was completed in 2009. The problem that it faces is that in 2015, the developers discovered that the building was sinking and tilting and released this information to the public in 2016. The foundation is a 10-foot thick concrete slab. It sits on 950 concrete friction piles that are driven 60 to 90 feet deep into a mud, fill, and sand, which is decidedly a poor type of ground for such a large structure. Other buildings in this part of San Francisco use end-bearing piles, which load directly onto the bedrock, as we discussed in Chapter 12. So, if end-bearing piles had been used for the Millennium Tower, they would have had to have been about 200 feet deep in order to sit on bedrock, basically 3 times longer than the friction piling that was used. In 2016, investigations showed that the building had sank 16 inches with a 2-inch tilt at the base and a 6-inch tilt at the top of the tower. There's a parallel to the Tower of Pisa, and there's a further one as we get further into the presentation. And the building is leaning toward the southeast. So now we know what the problem is. Let's look at who is to blame and who is pointing fingers at who. So first of all, the developers, Millenium Partners, blames the problem on the Transbay Joint Powers Authority and their Transbay Transit Center that was built nearby. However, it is noted that the sinking problem for the tower had started before Transbay Transit Center had started construction. Then the building's homeowners association decided to sue the builder, the developer, and the Transbay Joint Powers Authority, while another group of tenants is suing the developer, the City of San Francisco, and the Transbay Joint Powers Authority. And then finally, in November of 2016, the City of San Francisco sued the developers, Mission Street Developers, which is an affiliate of Millenium Partners. They claim the developers withheld information on the sinking problems from potential apartment buyers. And of course, the developers rejected the city's claim. So that's where the situation stands. So, some solutions. The developer hired a company called Sage Engineers to do a study. Some experts have suggested that the cost to fix it could exceed the liability insurance held by the developer. If the TJPA is found to be at fault, then the taxpayers are going to be on the hook for any repairs. And as of 2017, city inspection said the building is still safe to occupy, although there's been some foundation and electrical system damage. And based on the current information online, that remains the same to date, that the building is still safe to occupy. Now, some background. The developers paid for an independent review of the tower before it was built, but not of the site on which it sits. They hired a professor of structural engineering at UC Berkeley to conduct an independent peer review of the building design. The professor says he inspected the high-rise's design from top to bottom, but did not look below the tower. This would be a geotechnical review, and it wasn't part of the process because no one ever hired a geotechnical engineer. So what goes on, as we've talked in chapter 11 and 12, the condition of the dirt matters because it relies upon the properties of the soil to keep the building in place. That's what a friction pile does. As an Iowa State design professor explained it, imagine driving a broomstick into beach sand. You can only go so far before there's enough broomstick in contact with the sand to put up fearsome resistance. This has always been a standard technique for building in liquid soil, and that's why coastal construction always comes with the dulcet tones of a pile driver. So here we have a building that's sitting on hundreds of these concrete sticks, relying upon soil friction to hold the slab that sits on them in place. So the behavior of that soil is going to matter. The professor told the supervisors for San Francisco that all he said in his report was that the foundation was up to code, not that the foundation would work as the developers and designers intended it to, adding that he was not qualified to do that. So one of the city supervisors pressed the professor on why he didn't insist on a soil analysis, stating that the professor's letter said he's reviewed the design criteria and finds it acceptable, but doesn't suggest that they get a geotechnical consultant. To which the professor replied, "It wasn't my place." He pointed out that many projects opt not to examine the soil, and since the foundations must be built first, the developers are eager to expedite its review. Just an aside here, there is an American Society of Civil Engineers Code of Ethics, which I'd have to examine it, but I would suspect that this professor has violated some of them because he should have made that comment. Whether it was his place or whether he wasn't hired to do it, he should have said some caveat that without a geotechnical consultant, his analysis was worthless. So let's go back over after all this explanation and remember what we're dealing with. 58-story condominium skyscraper. The building is sinking and tilting, and it sits on a 10-foot thick mat foundation held in place by 950 reinforced concrete piles that are sunk 60 to 90 feet deep into the clay and mud but do not reach the bedrock. So some proposed solutions. One is to drill piles down into the bedrock, stabilizing one side of the tower. Then let the other side continue to sink until the building straightens itself out, which is very similar to what was done for the Tower of Pisa. They estimate that the job could cost anywhere from $200 to $500 million, and compare that to the fact that the cost to build the tower in the first place was $350 million. So engineers have proposed boring 275 to 300 steel and concrete micropiles down to bedrock, but only on the west side of the building at a time, and working inside the basement. Once they've stabilized the west side, they'll allow the east side to sink allowing the building to straighten itself. And we saw that that almost didn't work with the Tower of Pisa. Then they can add the rest of the piles drilled to bedrock on the east side that keeps everything from sinking any further, noting that the entire process could take 2 to 5 years. A lawyer representing the 265 owners thought that the only real fix was to tear the building down and rebuild it, noting that it might cost a couple of $1 billion to do that. One owner said, "I'm not an engineer, but the building is not made of rubber, it's made of concrete." He has a condo on the 57th floor with sloping floors, and stating that no one has proved to me that the concrete pad is stable enough to withstand 300 micropiles going into it. Note that if you recall, we talked about micropiles being used in the rehabilitation of Wrigley Field because they are small and don't require a lot of space, and you can work around underground utilities. And this is an example of what a micropile looked like, and there is a article that will be on Blackboard describing a little bit more about micropiles. And that ends the presentation on the Millenium Tower.